Hi, welcome to Basic Electrical Engineering Module 1, that is DC circuits. Today we'll discuss about some terminologies. The first one is the active and passive elements. So what is active and passive element? The active element are those components which produce the energy in the form of voltage or current. These are called the active components. So if you want to write the definition, these are the devices which produce energy in the form of voltage or current. Examples of the active elements are voltage source, and current source. We will discuss about the voltage source and current source later in this lecture. Next, come to the second part, that is called the passive element. The passive element are the components which can store or dissipate the energy but cannot generate the energy in the form of voltage or current. So these are the devices components that can store or dissipate the energy but cannot generate the energy in the form of voltage or current. The examples of the passive elements are resistors, inductors, capacitors, diode, etc. There are some basic characteristics of the active and passive elements. So if we want to discuss about the characteristics, of the active and passive elements, we can consider it as a comparison between active and passive elements also. The first one is that the active devices inject the power to the circuit, whereas passive elements are incapable of supplying the energy. So active element can supply energy to the circuit, but passive element cannot. It is also discussed in the definition of the active and passive element. This is the basic difference between the active and passive elements. The second point is that the active devices are capable of providing power gain and passive devices are incapable of providing the power gain. So for active element, the power gain is possible, but in passive element, it is not possible. Power gain not possible. The third point is that the active devices can control the current flow within the circuit, whereas the passive devices cannot control it. So the active devices or elements can control the current flow in the circuit. Whereas the passive element cannot. So these are some basic characteristics of the active and passive elements. We will discuss in details about the active elements in the next chapter. Now the voltage source. It is basically a two-terminal device which provides a constant potential difference across the load terminal, irrespective of the load resistance value. Now this type of voltage source is called ideal voltage source. And in case of ideal voltage source, it is considered as the internal resistance is equal to 0. But practically the ideal voltage source cannot be obtained. That means there should be some amount of internal resistance, although the value of the internal resistance is very, very low. In other words, we can also define the voltage source as the energy source whose internal resistance is much less than the load resistance. This can be also considered as the voltage source. Now the symbolic representation of the voltage source is so this is the symbolic representation of the voltage source. It can be represented by this, where the this plate is considered as a positive plate and this is considered as a negative plate. Sometimes the voltage source is also represented by this symbol, and here it will be represented as plus and minus. The circuit diagram of the ideal voltage source and the corresponding characteristics can be shown. Suppose if we apply a ideal voltage source, this is a load terminal A and B, and some load resistance is connected here. So the voltage across the load will be constant where VAB is the voltage across the load, and it will be constant with respect to current or time. So this is considered as the ideal voltage source. But already I have mentioned that the ideal voltage source is not possible. That means there should be some internal resistance of any type of energy source. So if we consider a practical voltage source, in practical voltage source, the voltage source should have some internal resistance. And this is the load terminal, and a load resistance RL is connected. So the current will flow so this is the voltage source value V. R in is the internal resistance and RL is the load resistance. It is a practical voltage source. So if we want to draw the characteristics of a practical voltage source, so VAB is the voltage across the load terminal, and in x-axis we represent current or time. So you can notice that if the load resistance is increased, if the current is increased, then the voltage across the load is gradually decreased. This is because of, if the current in the circuit is gradually increasing, then there will be a voltage drop across the internal resistance of the source. Therefore, the voltage that will be obtained across the load resistance, it will be gradually decreased, and this is because of the voltage drop in the in the internal resistance of the voltage source. Some examples of the voltage source are like batteries, generators, etc. So this type of energy sources, that is battery, generator, they can supply almost a constant potential difference across the load. Now the current source. Current source is a two-terminal circuit element, active element, which supply the constant current through the load irrespective of the load resistance value. Remember one thing, the current source supply the current which is independent of the voltage across the terminal. In general, the current source has a very high resistance. In ideal condition, in ideal current source, the internal resistance is considered as infinity. But again, the ideal current source is not possible. So in actual current source, in practical current source, there should be some internal resistance, and it is considered as connected across the source. In other words, the current source can be defined as, it is the energy source which has the internal resistance much greater than of the load resistance value. The symbolic representation of a current source is where the arrow sign indicates the direction of the current from the source. For an ideal current source, the circuit element can be shown as, this is the current source and the load resistance is connected here. So the current through the load will be constant with respect to the voltage or the time, that is voltage across the load or the time. So this is the concept of the current source, ideal current source. But if we consider the practical current source, which should have some resistance, then the circuit will be look like so I is the value of the current source, R in is the internal resistance of the source, and RL is the load resistance. Remember one thing here, the internal resistance is much greater than the load resistance. So the current flowing through the load resistance can be represented with respect to the voltage across a load terminal or the time, and it can be represented as this. That means if the resistance is gradually increasing, if the voltage across the terminal is gradually increasing, then some current will flow through the internal resistance of the source. Therefore, the current through the load will be gradually decreasing. There are some examples of the current source. It is photovoltaic cell or PV cell. We can also call it as a solar cell. And also the collector current of transistor. So these are called the current source, example of the current source. Now the concept of linearity and linear network. Generally the word linear means a straight line which looks like a diagonal, and it tells about the linear characteristics between voltage and current. That is, current flow in a circuit is directly proportional to the voltage. It means in the circuit, if the voltage is increased, then the current will also be increased in direct proportion, and vice versa. Now, let's say there is a resistive circuit R, and we apply a DC voltage source across the resistance, so a current will flow through the element. According to the Ohm's law, we know that V is equal to I into R. Now, if we want to draw the V versus I characteristics, then the characteristics of this circuit will be a straight line passing through the origin. Means when the voltage is 0, the current will also be equal to 0, because from Ohm's law we can write I equal to V upon R. And as the voltage is gradually increasing, the current will also be increased in the same proportion. Now this slope is called as the resistance. Remember one thing, if the value of the resistance is increasing, that means in this circuit, if we increase the resistance value, then the slope will also be increased. Suppose this one and so on. Let's say this is R1 and this is for R2. So in this case, the R2 is greater than R1. But in both the cases, the V versus I characteristics will be a straight line. The elements which follow this linearity, that means where the V versus I characteristics is a straight line, then these elements are called as a linear element. So the linear elements are the elements where the voltage and current characteristics is in direct proportions. The examples of the linear elements are resistors, inductors, capacitor, and so on. So linear element are the elements for which the voltage and the current is directly proportional to each other, and the circuit or network that consists of the linear elements are called the linear circuit or the linear network. Now the nonlinear circuit and nonlinear elements. These are the elements which does not have any linear relationship between voltage and current. For example, diode, transistor, then vacuum tube, other electronic devices, etc. And the circuit that is made by these nonlinear elements are called the nonlinear circuit or the network. For example, if we consider a diode, we know that the diode can be either forward biased or reverse biased. So in this case, the diode is in forward biased. Let's say I is the current flowing through the diode and the voltage across the diode is V. Similarly, if we connect the diode in reverse biased, then the polarity across the diode will be changed. So this is the diode in reverse biased. So this is the forward biased and this is the reverse biased. So if we want to draw the characteristics of a diode between voltage and currents, then we can see that in case of forward biased, the nature of the current will be exponentially increased with the increase with the voltage. That means if we increase the voltage across the diode gradually, the current will be increased exponentially. Whereas if we connect the diode in reverse biased, that means the polarity across the diodes are changed, then the current will be flowing in the opposite direction and it will follow this line. So definitely the voltage and current characteristics for a diode is not a straight line. It is not the linear. That's why it is called the linear element. And if there is any circuit with the diodes, then this circuit will be considered as the nonlinear circuit. The next terms comes as the bilateral and unilateral elements. First of all, we will consider the bilateral element. In bilateral element, the conduction of the current in both directions in those elements are with the same magnitude. These are called the bilateral elements. That means it allows the flow of current in both the directions. Remember one thing, in bilateral circuit, the property of the circuit does not change with the change in direction of the supply voltage or current. The example of the bilateral elements are resistors, inductors, capacitors. Let's take an example. Suppose we have a resistor of resistance R and the polarity across the resistance are as shown. So a current will flow through the resistor and it will be I. If the voltage across the resistor is considered as V, then the value of the current will be equal to V upon R. Now take the second example. The same resistor, but in this case the polarity across the resistors are changed. Again the voltage across the resistor is V. So in this case we will see that the current will flow from right to left. And if we apply the Ohm's law, again the value of the current will be V upon R. That means in case of resistors, if the polarity across the resistors are changed, the direction of the current will be changed, but its magnitude will be same. This type of elements are called the bilateral elements. On the other hand, if we consider the unilateral element, so the unilateral elements are the elements where the conduction of the current is in one direction only. That means the property of the circuit will be changed if we change the polarity of the supply voltage. The example of the unilateral elements are again diode, transistor, etc. Now take the example of the diode. In case of forward biased condition, the polarity of the diode should be as shown here. So the current will flow from positive to negative terminals. And for reverse biased condition, the polarity of the diode will be changed. So in this case, the current will flow in the opposite direction. Now, if you draw the V versus I characteristics here, as we have already seen in the previous case, so when the polarity of the diode is as per the forward biased condition, then the current direction and the magnitude will be in the first quadrant and it will follow the exponential increase. Whereas the diodes are connected in reverse biased, then the polarity, the direction of the current and the polarity will be changed and it will be in the third quadrant. So in this case, the direction as well as the magnitude of the current will be changed with the change in polarity across the diode. So this is called the unilateral elements. The circuit which is made by the bilateral elements are called the bilateral circuits, and the circuits which are made by the unilateral elements are called the unilateral circuits. Before we proceed further, we have to know the difference between network and circuit. An electrical network is an interconnection of various electrical elements like resistor, inductor, capacitor, voltage source, current source, etc. The electrical networks can either be closed or open path. That means various electrical components should be interconnected, and any of the branch or any of the terminals may or may not be opened. Then it will be considered as a network. On the other hand, the electrical circuit is a network which has a closed path, and that gives the return path for the flow of current. That means the electrical circuits are always closed. Let's have an example. Suppose with some voltage source and some resistances, we have interconnected some resistances and some voltage source. So it is the interconnection of two voltage sources and three resistors. But here the terminal A and B are made opened. So it can be considered as a network. It is not a circuit by definition. But if we make another interconnection of resistance and voltage source, so it is almost same as that of previous interconnections of elements, but here the terminal A and B are joined by another resistor, that is the RL. In this case, it makes a closed path, so it can be considered as a circuit. Remember one thing, the second interconnection is a circuit, but it can be also considered as a network. But in the first case, it will be always considered as a network. By definition, technically it cannot be considered as a circuit. Before we proceed further for circuit analysis, we have to remember some more definitions that is related to the circuits. So the first one is called the loop. Loop is basically a closed path formed by starting at a node, passing through a set of nodes and returning to the starting node without passing through any other nodes more than once. The second definition is called mesh. Mesh is a smallest closed path, or it can be considered as the smallest loop of the circuit that has no other branches inside it. The next definition is called the node. Node is a point in a circuit at which two or more elements meet together. For two nodes to be different, then their potential must be also different. The next definition is called the junction. Junction is also a node or a point where three or more elements or branches meet together. So it is basically considered as a collection of the conductors at the same potential. Remember one thing, all the junctions can be considered as a node, but all the nodes cannot be considered as a junction, because junction is where 3 or more branches are connected, node where 2 or more branches are connected. The next definition is the branch. Branch is a path that connecting two nodes and should have a circuit element between the nodes. The circuit elements may be resistor, inductor, capacitor, or energy sources, either voltage source or current source. It can be also considered as the number of branch in a circuit is equal to the number of elements that present in the circuit. Let's consider this circuit and we will explain all the definitions by using this circuit. The first one is called the loop. So loop is the closed path of a circuit. So if we consider this circuit, here we have total 3 number of loops. The first closed path is considered as A, B, E, F and A. So it is one loop. The second one is B, C, D, E and B. Again this is another loop. And if we consider the whole circuit, that is A, B, C, D, E, F and then A, then it is another loop. So in this way, in the given circuit, we have total 3 number of loops. Loop 1, loop 2 and the whole is another loop, that is the third loop. If we consider the mesh, so in this case we have only 2 meshes. The first one is called A, B, E, F, A. This is mesh 1, and B, C, D, E, B, it is another mesh, because mesh is the smallest closed path which should not have any other element within it. So in this way you have total 3 number of loops and 2 number of meshes in the given circuit. Next, the number of junctions and the number of nodes. In this circuit we have total 6 number of nodes, that is A, B, C, D, E and F. Because node is the point where 2 or more elements are joined together. So at point A, voltage source and R1 is connected. At point B, R1, R3 and R4 connected. At point C, R4 and R6 connected. In this way, at point D, R5 and R6. At point E, R2, R3 and R5. And at point F, the voltage source and R2. So we have total 6 number of nodes in the given circuit. And the number of junctions. Junctions is a point where 3 or more branches are connected. So in this circuit we have only 2 junctions, that is point B and point E. Because at point B, R1, R3, R4, total 3 resistances are connected here. Similarly at point E, R2, R3 and R5, again 3 resistances are connected. So B and E are considered as the junction. So in this circuit we have total 6 number of nodes and 2 number of junctions. Then the branch. Branch is a part between 2 nodes which should have at least one circuit element. So AB is considered as a branch because between A and B, R1 is the resistance. Similarly, between B and C, R4 is the resistance. So again, B and C is the branch. In this way, we have 1, 2, 3, 4, 5, 6 and 7. Total 7 number of branches we have in this circuit. So you have total 7 number of branches. Now we have to know some more definitions that will be useful for our circuit analysis, and this is considered as a short circuit and open circuit. So the definition of the short circuit, or what does it mean? The short circuit means when the resistance between 2 terminals becomes 0, then this condition is considered as a short circuit. And similarly, when the resistance between two terminals becomes infinity, then it will be considered as the open circuit condition. Let's have some example. Suppose in this given circuit, I have drawn a simple circuit with a voltage source V. R1 is the resistance and RL is the load resistance. A and B is the load terminal. According to the condition, we have to short circuit the load terminal, that is terminal A and B. Then what we will do, we will simply remove the load resistance from the circuit and we will join the terminals A and B by using wires, because wires have zero resistance. So in this case, it will become a short circuit path. And the current that will flow through this short circuit path is considered as a short circuit current. Remember one thing, in the short circuit path, the resistance will always be equal to 0. Now for the example of the open circuit, we have another circuit, voltage source, R1 is the resistance, RL is the load resistance, and we have to make the load terminal open. So what we will do, we will simply remove the load resistance from the terminals between A and B. So if we open this terminal, it will become a open circuit condition. And remember one thing, for open circuit condition, the resistance between A and B is considered as infinity. It is considered as an infinity resistance. And as the resistance is infinity, then in case of open circuit, no current will flow in between A and B terminals.